Well, greetings, everybody. Guess what somebody just brought me the other day? It's a 1947 Westinghouse Model H 157, I believe. Yes, it is. And the fellow that brought me this picked it up at a flea market, and he wanted to know what it would cost to restore it, partially restored, actually, just to get it working. So I think what we're going to do is basically do a partial restore on it and maybe get it working. He says that he plugged it in, which I don't recommend anybody do for something they just bought cold like that. That's not a good idea. But he did it, and all he got out of it was a buzz. So I suspect maybe filter capacitors. But let's go ahead and plug it in on the variac and the dim bulb current limiter, and we'll see what happens when we bring it up slowly like that. And if that sounds interesting to you, stay tuned. We'll get right to it. And as we take a little closer look at it here, you can see it's pretty dusty. It has some good buildup of 70 to 80 years of dirt. I think there's a little badge missing here for the tuner. The volume control, as you can see right there, is still intact, as well as the brand badge there. And on the bottom we have the tube layout chart and the model number for it. It doesn't really say the year, but what I've looked up on the internet was it was built somewhere between 1947 and 1948. Now, it does have the obligatory white paint speckles, and I don't know why this is, but almost every vintage piece of equipment has white paint speckles on it. And the only thing this one is missing is the cigarette burn on top, which usually that comes on guitar amps, but on the radio here it has that. So I think we'll probably leave that because it's kind of a classic vintage relicing on it. Now on the back we have all octal tubes, and I don't know if it's supposed to have had a back on it here or not, but the loop antenna is built into the cabinet, so it's not part of the back. So I don't even know if it even came with one, although there's a little cutout here for it. I'll have to do a little research on that and see what it is. The speaker on the back looks like it's in pretty good shape. I don't see any tears from this end, but I think we'll take it out and look at it. Now, one thing that's very interesting about this is that you'll notice instead of the old regular All-American 5, this has 6 tubes in it. I think it's 6, 3, 4, 5, 6. Yeah, this one has 6 tubes in it, and 2 of them over here are 25 L6s. Now, normally on a 5-tube superhet like this, you'll have a 50 L6 for an output tube right here. But on this one, it's a little bit different. As you can see on the schematic here, it has 2 25 L6s in a push-pull configuration, which is quite unusual for a table radio. This thing must have a lot of power output to it. So it's going to be interesting to see how that plays out when we get it working and up to its normal operating characteristics. So other than that, nothing too unusual about it. It has a 25Z6 for rectifier tube, which is a full wave rectifier. That's kind of nice. Looks like they're using it in a half wave configuration though. As you can see, the plates and the cathodes are tied together here. And then we have 2 filter capacitors right down here that will probably, I'm sure they'll need to be replaced, but we'll go ahead and bring it up on the variac and we'll show you what that sounds like. That way we won't, if something goes wrong, we won't burn anything up in here. We'll just light up the dim bulb. So let's get that started and we'll go from there. Well, before we find out where we're going, we need to know where we're at. So I'm going to plug this into our dim bulb current limiter. And first of all, we'll turn the volume up about halfway to 3/4 and take a look at the line cord here. The line cord's in remarkably good condition. I don't know if it's original or not, but it's fairly old, just judging by the non-polarized plug on the end here. So I'm going to plug it into our dim bulb current limiter up here. Get a shot of that. And we'll plug it in right here. And I've changed the bulb out to a 100-watt limiter. And so we will go ahead and I'll move this over here to where we can get a little better shot at it. And here's our variac, here's our dim bulb current limiter, and this is the radio, of course. So let's go ahead and turn on the variac and we'll start advancing it. I think I'm going to, I don't know if you can see the voltage on this yet or not. There it is up in the upper right hand corner. We're going to turn this up. We're going to start out at about 50 volts. And we'll notice the dim bulb is starting to glow a little bit. And we have some light in the radio here. That would be the pilot light. And it looks like somebody put a Christmas light in there, so we might have to change that. I don't know. We'll have to check on that. But we'll let it warm up there a little bit. Looks like the current limiter is slowed down now. We'll advance it a few more volts. We'll take it up to about 70 volts. And we got a buzz, so let's see if we can tune in a station here and see if that a little bit of something wants to come in there. Give it just a little more voltage, maybe up to 7. Let's take it to 80 volts. Yeah, there's a station that wants to come in there, but the hum is so great. So I'm going to shut this off. Okay, so that tells me the filter capacitors are totally gone. I think probably that I don't think they're shorted, just judging by the current limiter is not even lighting up now, but the 60 cycle hum is just way over the top. So looks like we've got some open filter capacitors, and I'll go ahead and pull this chassis out of the radio and we can take a look at maybe bridging those just to check them, but I'm sure that's what it is. So that's what we'll do in the next step. Well, before we get too involved in the electronic restoration of this unit, I think we're going to go ahead and test the tubes in it just to make sure we don't do a lot of unnecessary work here. So first one we're going to check is this 25Z6. Now I've got the tubes tester set up we have the line adjust all set and the filament voltage and the element select and the load all set up. So let's plug it in and see what happens here. Okay. And looks like we've got some pretty good emission on this one, up to almost 100 and Well, I think that's 120 on that meter. Yeah, 120 nearly. And let's go to the next section, which 25 Z6 will be the G position here. And it's reading pretty much the same thing, which is a good thing for a dual rectifier tube. Let's go ahead and check for shorts on this. And we'll give it a little tap test here. Looks like we might have something going on with either the tube or the socket itself. This is an old tube tester, so it's hard to say. Let's tap it a little more here. It's staying pretty well in the good section. Let's try the D section here. We might have to try another tube tester on this. I'm not sure that's a problem with the socket or the tube itself. I'll have to see if I can dig out another tube and see if that works. Well, since I wasn't sure that the tube tester was working properly, I decided to drag out my even older vintage triplet checker here. And we got the tube in it now, and it's all set up. It shows the emission is good on it. Right here, you go over there, and it has good emission. But when you go to the short test and check for shorts on pin 7 here, it lights up pretty bright. And so I think we're dealing with a bad rectifier tube here. So I'm going to have to see about getting one of those. And also one of the other tubes I tested over here, this 25L6, that you can see it's part of the push-pull audio output stage, is also badly shorted. And so we're going to have to scare up one of those too. Well, I went ahead and replaced some of the tubes in here, 3 of them that I got as new old stock from 1951 through 1959. They are joint Army-Navy military spec tubes, so they should last a long time and come up really well. I also replaced the filter capacitor to get rid of the buzz in the circuit, and a new pilot light there. So let's turn it on. Let's see what happens when it warms up. Hopefully we'll get some noise out of it. Oh, there we go.
No matter what you do, I'll do it better.
Yeah, we got one station anyway. That's around KRSL and oh, that receives pretty well, I think. So I'm going to turn that down a little bit. Anyway, looks like it's going to work. Now I still need to go through and replace all the capacitors and the out of tolerance resistors and make this chassis safe for general use. And we'll be done, and it'll take me a little while to do that, but we have a working radio, so we're on our way. Now that I have the tubes in and we know the radio is going to tune just fine, I went ahead and restored the rest of the electronics in this, and let me show you what I did to it. First off, the filter capacitors, here's one right here and one right here. We got rid of that big ugly red one here and replaced it with these 2 smaller electrolytics. got rid of all the wax capacitors and electrolytic capacitors and replaced them with these. As you can see, they're quite a lot smaller, and which makes it a lot easier to work on now that I have a little room to move around in. And we've got that done. I also added a fuse holder right down here in line with the power cord, so that makes things a little bit safer. Also put on a polarized plug for the end of it, which is hanging around here somewhere. There we go, right here. And you can see that it is polarized unit. And replaced all the resistors that were out of tolerance, and there were quite a few, which surprised me. Even not only the little brown roundies that were out of tolerance, I replaced quite a few of the Allen Bradley squared off ones too. So we did that. And on the front, we started the cleanup of the chassis, and we got the front dial all cleaned up and prettied up. Replaced the little rubber anti-vibration mounts, and that cleaned up the chassis pretty well. Let me put that in the chassis holder here and replace the dial light bulb, which is a screw-in type. This is just basically a night light. And we polished up the chassis as best we could. There was some rust over in this area that really couldn't do anything about, so I just left that and cleaned up the capacitor a little bit here, the tuning cap, and replaced this capacitor for the antenna circuit. These 3 tubes, the rest of them were good, so we didn't have to do anything with those. Now, I think in the next step, I'll go ahead and begin working on the how to tune it up and get the IF transformers aligned here, which is not a big deal for an old AM radio. And I'll show you how to do that with using just the minimum of test equipment. So you don't need a whole lot of stuff to work on these things. Unless something goes terribly wrong, then you might need some special test equipment. But as far as just aligning it, it's not a big deal. So now, before I show you the big reveal about the cabinet and things, I want to show you what I did to the front of the grill cloth here. This is the original grill cloth, and if you're ever wondering if you were to easily find a place to get this, I found almost identical stuff down at Hobby Lobby. It's just a burlap replacement. But I really didn't need it on this because this was in pretty good shape yet, so all I had to do was stretch it out a little bit and staple it. Then, well, before I did that, I glued it, but then put some staples in it to hold it, and it tightened up real nice here. And it fits in the chassis really, or not the chassis, but the cabinet really well here. I'll show you what this looks like on the front. Which is right here. So that came out pretty well, and the chassis or the cabinet, I was able to pick off a lot of those ugly white spots on it, and I'll show you what I did. Take this out. And I wasn't going to do this. I was just going to let it go, but I couldn't do it. I had to do something about it. So I didn't do any sanding on it or anything like that. All I did was to chip off some of those white paint specks, and then I went over it with a coat of Danish oil, and it really got rid of the Mars. It had some deep, ugly scratches in it, and it really took those away. The scratches are still there, but you can't see them anymore, and it really put a shine on it. And so I really didn't do any sanding or anything on this, just went over that. Of course, clean the glass here with some, I use just some eyeglass cleaner because it's very pure and it doesn't leave any streaks or any weird stuff, fingerprints or anything like that. But went over that, got it all cleaned up. And then on the last thing I did was just went over it with a coating of plain old Johnson's paste wax that my mother used to use on our kitchen floor once a week. And that was a long time ago, you can imagine. So anyway, just went over it with that and it shined up really nice. I'm really happy with that, with a minimum of effort. One other thing I did was also the little badge here for the tune was missing. So I tried to replicate that in Affinity Photo and made a badge for it. So it came out really well. Didn't do anything to the bottom. Didn't need to. So we'll go ahead and get to going on the alignment. But that's all I did to this. And of course, we'll need to put this back in, and it has a whole bunch of screws that go on the side. We'll stick it back in there and come back and we'll do the alignment. Well, the time has come to do the final alignment of our newly repaired and restored AM radio. What I did is I got out the instructions for doing this, because there's several different ways you can align one of these, but this one I'm going to show you is what they recommend is you turn the tuning capacitor fully closed, set the pointer to the last reference mark at the low end of the dial, which I did, but it doesn't really track all that great. I don't know if they ever intended it to do that, but it doesn't really. But we'll try to get by here and use an isolation transformer, which we are doing. And I've got the voltage set up to 120 volts. And we're going to deviate from this a little bit here because I have an easier way to do this, and especially if you don't have a lot of test equipment and are not real comfortable about poking around inside the radio and connecting up capacitors and things to areas where you could get shocked or something. So I've got a different way to do this. What you will need is basically a non-conductive alignment tool like you see right here. And if you don't have that, you can use on this radio at least, a metallic screwdriver with a piece of insulation coating the end. I use a piece of heat shrink tubing, but you could use electrician's tape or whatever you want to use. But I want to show you the reason why, before we get started, that you should not use a metallic screwdriver when aligning these IF transformers. Now on these old radios, at least prior to 1950, the IF transformers, which you see right here, have little capacitors here. Instead of a tuning slug, a ferrite core tuning slug that's usually used after 1950, they use these trimmer capacitors instead, and they look just like this one you see right here for the antenna. And they put them in here. Now, I like these better because you don't run the risk of fracturing the iron or the ferrite core transformer core, because if this thing's 7 years old like this one is, or even older, they're usually jammed in there, and you try to loosen them up and you usually end up breaking them. But these we don't have that problem with. But the reason why I don't recommend a metal screwdriver, and I'll show you why. Let me get the schematic out here. Okay, we're going to look at the schematic and the IF transformers. You can see here's our first one, and we'll use this as an example. Now, you see the capacitors right here on the primary and the secondary. That is these trimmer caps that you see there. Now, the problem with these is a trimmer cap like this one side of the capacitor is almost always attached to the adjustment screw, both physically and electronically. So basically, you are touching live circuitry when you get in there with a screwdriver. And unfortunately, what happens is, if you'll notice here on the schematic, part of this tuning capacitor, if you follow it down here and follow this line across and down and over here, it goes directly to the B plus high voltage supply of the power supply to the radio. Now, what happens, you can guess, when you come in here with a metallic screwdriver and you put it on that screw and accidentally just nudge it over a 1/16 of an inch against the metal shield of the transformer. Well, what's going to happen, as you can guess, is you're going to short out your B plus supply, and that's a lot of voltage backed up with a lot of current through these filter capacitors, and you will, at the very least, blow the fuse or overload the power supply, possibly take out this resistor. But the worst thing is, let's say this part is actually the one that will be grounded. And if you ground that, the power is going to go right through the coil of your IF transformer. And as soon as you touch the ground or the shield of that transformer, you're going to take out that IF transformer and you're going to be looking for a replacement in a heartbeat. And so that's very dangerous, and you need to use a lot of caution. Don't ever stick a metal screwdriver in there unless it has some kind of insulating coating on the edge of it. And the only reason I do that is because sometimes when these are old, they're a little hard to break loose. And really, when you're in there with a little plastic wand like this, you end up breaking the tip off, which is no big deal, but it's hard to do. So once you get them loose, switch back to a non-conductive alignment tool. Okay, so let's go ahead and get started. I'm going to begin this with a minimum of test equipment. Now, I'm going to show you two ways to do this. And the first way, the only thing you really need is some kind of signal generator. And I have a little tiny SA generator here that you can see that I'm using on this one. And you don't even have to make any direct connection. It has an antenna on it, and it'll radiate enough signal to do what we need to do. Or you can use just a standard AM signal generator, but you'll want to have something where you can modulate it with about 400 hertz of audio so you can hear a tone through it. And that's all you need, really. And like I say, if you wait till the end, I'll show you how to do this without any test equipment. All you need is a wand. So the other piece of test equipment I have is this old multimeter. It's an analog meter. Digital would work fine, but you'll see the beauty and the advantages of having an analog meter that has a needle that actually swings back and forth. So it's very, very easy to read your peak when you do this. So we've got the meter. The leads come over here to the speaker. And I'll show you that just a little bit here. You can see it right there is where the attachment leads are. And according to the manual here, we need to start with the tuning capacitor fully open. And I'm going to deviate again from this. So we're going to fully open the tuning cap, as you can see right here. And this is the oscillator capacitor. It's always a smaller one. And this is the antenna capacitor, and it's a larger one. Both of them have trimmers on it. Now this one, it's an older radio, so they actually put a trimmer separate from down here, which makes it a little easier to reach. This is the back of the radio, by the way. And it's easier to reach than trying to get in there and do this vertically. Also, they do this because it has you can use an external antenna on this and use that as the antenna trimmer, which I can see now why they didn't want to put it there. But the other thing on this radio is they recommend you put the radio roughly the same position as it would be in the chassis, at least along the same plane. So you don't want it 90 degrees to the antenna coil that you can see right here. You want it in line with it because that's the way it was designed. And what I've got is the signal generator set up to approximately 1.615. Let me restate that. It's 1.615 megahertz, and modulation's 400 hertz AM. And it's a low signal as we can get on that and still pick it up. And as you can hear it there. And so we want to use as low a signal as possible, because if you use a really strong signal, the automatic volume control circuitry in the radio will kick in and you won't get a proper peak. So you want to use a low signal as you can possibly have. So we've got that at 16 with the gang fully open. So we know that's right. And we adjust A5, which is this trimmer right here. That's our oscillator. Oh, that one's tight. So, like I said earlier, we're just about going to have to use a metal screwdriver for this. And turn the volume up and okay. So we've got the volume turned up on that, and it's peaked out. And now as the directions show here, is we should go to 1400 kilohertz and just A6, which is the trimmer capacitor. Now, here where I live, we're blessed to have a radio station that is exactly 1400 kilohertz. So, and it's very strong, and so I really can't use that to adjust this. We're going to have to go a little bit off frequency from that, because as you can hear, it comes in quite strong, and that's just not good for adjusting peaks on the radio. The AVC will kick in and mess that up. So we'll go a little off frequency and see if we can find a station in here that I can broadcast on YouTube without getting dinged for copyright violation here. Doesn't look like there's anything out here that something right there. Let's see if that works. What we're going to do now is adjust the trimmer cap on the back of the radio right here for a peak volume. The adjustment's quite broad, so you might not even get a peak outside of maybe a whole 2 to 3 turns on that screw, but that's about the best we can do on that one right now. Now, the reason why they want you to do that at 14 kilohertz on the dial is that is basically the middle of the band. And this is kind of a logarithmic scale, so it's kind of compressed up here at the right-hand side. So electronically and frequency-wise, the middle of the band is right at 14 kilohertz. And this applies to all AM radios on the broadcast band, whether it's a car radio or any table radio or whatever. So we've got that one adjusted now to peak, and now we're just going to go through the IF strip and we're going to inject a signal somewhere in the IF strip to peak all our trimmer capacitors. But before we do that, we're going to check the band and see how the radio works. And now there is a station that's about 100 miles away. It's on 550 on the dial.
You've reached out for help.
And that's it right there.
Perhaps it's time to do for yourself what you would do for others.
And it's pretty close. It's tracking quite well. So now we know that our tuning or our oscillator is working quite well on that, and things are tracking very well. There's 16 again, 16, 15. We can actually test this by changing the frequency to like 1.5 megahertz. And let's go see how close we are to 15 on the dial. Well, it's pretty close. These old radios, they don't track very well, so if you can get in the ballpark, you're almost going to have to be happy with that, because there's not a whole lot you can do with it. Sometimes some radios will have a split capacitor here, like you see on the antenna section, where you can bend these tabs out a little bit, and that will change the tracking of the radio. So this one does not have that, so I can't really change the tracking here, but we're just stuck with what we can get. If you tune it around 14 on the dial, that's pretty much average across the whole band. So we're going to go with that, and let's see how close we are to 1 megahertz. We'll just change the frequency here to 1 megahertz. And that's pretty close. Now what we can do is, once you get it in the ballpark, you can shift the radio off a little bit. Just by pulling the pointer. Okay, that's 1. Now let's go to this 14. 14's right on the money. Let's see how 550 looks down here.
Okay. So now we are in a situation
where it looks pretty good too. So our dial's tracking quite well for an old radio. So we're just gonna stay here at 1 megahertz, which is 10 on the dial, and we're just going to finish up adjusting A1, A2, A3, and A4, which is the IF transformers, and basically we'll just peak them out. And I'll turn this way up so you can see the needle, and I'll shut up and stop talking. A2. That was A3, here's A4. Okay, we got those. Now what we'll want to do is go back over and do them all again, just to make sure we can got the peak on it. And I forgot to tell you, just set your meter to AC volts, the lowest voltage range you can get, and put your leads across the voice coil there. If you get tired of the tone, just put a resistor, 8 ohm resistor in there. So let's peak it out again. Well, a little change there. Now we have both IF transformers properly peaked. Now we should have a pretty hot little radio. So it was a little bit out of tune there, so let's see what we can pick up this evening.
Tommy Lamb.
That's really stopping all the pro-policing legislation.
Not too shabby.
Elimination game between the Warriors and the Kings. Winner of Lakers Pels draws.
Not too shabby for a band that's supposedly technically dead now. We've got a lot of stations you could listen to, at least we do here in Kansas. So that completes the alignment on this, really. As I promised you, I was going to show you how to do this without any test equipment. And it's very simple. You're probably going to kill me on this, but you don't need the meter. You don't need the generator. All you need to know is the local radio stations in your area. If you know the frequency of them, you can use them as your signal generator. Like I said earlier, we have a local station right at 1400 kilohertz, which is very good for aligning radios. And also I have one at the other end of the band at 550. So if you know the frequency, you can do this whole thing. You can adjust your oscillator to match the dial. You can trim your antenna up, and you can peak out your IF transformers, and that's all there is to it. Well, the project is finished, and I thought I'd show it off a little bit here for you. The radio appears to be
first shots of the American Revolutionary War
quite selective,
as outnumbered
and very sensitive.
Kansas. No matter where you go.
driving the truck all day long.
Driving to work.
We're right there with you. AM 1190 KDSB, The Mix.
and very selective, very sensitive, and has pretty good noise rejection on it too, which surprises me. Being down here in the basement in my lab with all the electronic equipment going and LED lights and things, it's usually radios are very noisy down here, but this one seems to reject the noise pretty well, and I really am impressed with the way it works. The cabinet turned out really good. It's nice and shiny with a minimal effort using the Danish oil on it. The back cleaned up nice. Chassis came out very well. And all in all, I'm very happy with it. And sure my friend will enjoy it just as well. And replaced a lot of parts in it. But it's working, and like I said, I think he'll be happy about it. And I want to thank you guys for staying with me through this video. I know it ran a little longer than I anticipated, which is always the case, but maybe next time it'll be a little shorter. But I hope you learned something from it. Leave me a comment or whatever if you want to, or if you have any questions, leave me a comment, and I'll get back to you as soon as I can. But again, thanks for watching, and we'll catch you on the next video.